Day to all, Engineering Practices Laboratory, Group B, Electrical and Electronics part. So this is experiment 3. The title of experiment 3 is Industrial Wiring Using Switches, Fuse, Indicator and Energy Meter. So before we are going to start and explain for this experiment, we are need to know about so what is industrial wiring and where we are going to use for in that kind of industrial wiring. Okay, so and then we are need to know about the exact difference between industrial wiring and residential house wiring. So in that residential house wiring, we are used only in single phase power supply. In single phase, two lines will be there. One is a phase line and another one is a neutral line. In industrial wiring means totally 4 lines will be used. For that 4 lines, 3 line is a main phase line R, Y, B, and another one line is a neutral line. So residential house wiring. So another difference is in a residential, in our homes we are using low power equipments like iron box and lamp, ceiling fan, and then mixing grinder, that and all. Okay, so that and all equipments is a low power equipments. For in that low power, we are going to supply by a single phase line. It's enough to supply the power to low power equipments. Okay, so that's why we are used in a single phase for supply, and also single phase in low power equipments, it's consumed only minimum amount of current. So that minimum amount of current supplied by a single phase supply, it's enough to supply the low power machines. Okay, so in industries we are used much more high power rating of the equipments. For in that case, for in that high power, we are not able to supply by using of single phase line. So that's why we are going to use for 3 phase power line supply to supply the power to the high power machines. Okay, and also the high power machines consume the high amount of current. So in that high amount of current, from that single phase supply we can't able to supply. So that's why we are going to use a 3 phase line in an industrial side. Okay, so this is a basic apparatus required we are used in industrial wiring. So 3 phase energy meters it's required, and 3 phase resistive load it's required, and indicator lamp and connecting wires if we are used for in that experiments. So this is a general circuit diagram. So the 4 lines will be there for an industrial wiring. It's nearby post. We are taking that all line and given to the input of 3 phase energy meter. From that energy meter we are going to take that output and given to the main switch and fuses, and then we are going to given to the 3 phase load. Okay, so either in a 3 phase load, if we are used in a high power rating motors or any other machines if we are using in industries, we are going to supply this kind of circuits. Okay, in a 3 phase energy meter totally 8 terminals available. All the add 1, 3 and 5, 7, that all terminals it will be connected into the input line, and all the even terminals will be connected to the output. Okay, so this is a energy 3 phase energy meter terminal configurations. Okay, so these are all the basics of industrial wiring using such as fuse, indicator and energy meter experiment. Thank you.
This is the experimental connection of an industrial wiring. Here the input supply, 3 phase supply is get it from the EB source. One is R, Y, B, then N. So R means red, yellow, then blue, then black indicates a neutral wire. These are the 3 phase power supply, get it from the EB source, that is connected with the 3 phase energy meter. These 3 phase energy meter splitted into the 4 category. Here you can see the 4 category, 1, 2, 3, 4. Each category having 2 connections. First one is an input power supply, another one is an output. The input is get it from the EB source. The output is connected to the load. That load may be industry load, means the motor or either some other utilities. For that load, I am using the 3-phase resistive load for the laboratory purpose. Here, the R output from the meter is connected to the R of the load. Then yellow, the Y output is connected with the load. Similarly for B and neutral, if all the connections are made correctly, means if you switch on the MCB, automatically the indicator will on. We can check whether all the connections are correct, means red, yellow, then blue, the indicator will on. So now the connections are correct. That's why the 3 indicators on condition. We can check the voltage by using this, press this button here. We can check the voltage of the R. That's R voltage 253.60. Similarly for Y 244.29. Then B 252.16. So 3 voltages we get it. If you switch on the that the current becomes 0 because we didn't give any load to any load. So if you are on the load, what will happen means you will check it in the practical manner. Now I am going to switch on one load. So the load is on now condition. Let us check the same. So if you are checking the voltage level, so this is the R voltage 253, Y voltage 243, then B voltage 252. Now the current becomes 1.22 R. This is the current 1.18 Y. This is the current 1.24 B. So if your load is on, the current is increased. So as per your connections, the experiment is verified. If the load is running, means the call button, that means call indicator will on for particularly every seconds, that will on and off. So the load is gradually running. We can verify in the practical manner also in the meter. So this is the industrial wiring used to get the how the industries are used the wiring circuit and wiring setup. This is the this is the introduction about the industrial wiring sector.